Welcome, everybody, to SNIA's Storage Life on the Edge. This is a talk on security challenges. Not only a talk, but you get a bonus panel out of it as well. And here are our presenters today. I'm David McIntyre, so I'll be your friendly moderator. I'm currently a director of product planning over at Samsung. And my two distinguished panelists are today Thomas Rivera and Eric Hibbard. Look at all those letters. These two folks must be very important people in the security realm. Thomas coming from VMware and Eric coming from Samsung as well. Thomas, would you like to add some additional color to your background, and same to you, Eric?
And thanks, David. My name's Eric Hibbard, also with Samsung. And yes, I'm partial to the letters C and S, as it's obvious. Most of this is from past positions where I was involved with security and privacy as a practicing professional, but I'm also heavily involved in ISO and IEEE standardization, as well as SNIA's security technical activities in the security space.
Okay, great. Well, thanks, Thomas and Eric. First, I'd like to give our audience a little backgrounder on SNIA at a glance. So we have over 180 industry-leading organizations involved with SNIA and 2,500 active contributing members across those organizations. We have an outreach of 50,000 IT end users and storage pros worldwide that we educate, support, and provide leadership within. If you want to learn more, please go to snia.org/technical or Twitter at SNIA. Some of the technologies that we cover at SNIA range from networking to storage protocols to system level concerns, hyperconverged infrastructure, as well as security, which is why you're here today to hear from Thomas and Eric on that topic. Just a disclaimer for us, this material contained in this presentation is copyrighted by SNIA, and you're welcome to use the material, but you can't modify it. That's our only ask. And there are no warranties, express or implied. Use this material at your own risk, but it's good material. So the agenda today is I'm going to give just a brief table setting on what's going on at the edge. And then we're going to move into the specific topics, ISO perspective on edge computing, followed by security on the edge. And then we'll get into an illuminating panel discussion. So first of all, I will start this. Chaos at the edge. Look at all these things. This just gives me a headache just staring at it. But, you know, we have things from cloud service providers, CSPs, in these rain clouds above us. They're all interconnected one way, this way, and the other across edge networks and across edge cloud intermediary systems. Now you got the telcos with 5G involved. You also have cloudlets involved, where you're aggregating information and have assigned compute storage and networking resources there. Then you have all these IoT applications down below, from smart city to drones to automotive to cell phones. Oh my gosh, what are we going to do with all of this? Well, we're going to try and make some sense of this, all the different permutations of data here, at least from a security and a privacy perspective today. So, but before you jump into the security deep end, I just wanted to give you this reference that this is actually the third in a series of webcasts that we provided on this topic. The first was storage life on the edge, managing data from the edge to the cloud and back. The second was storage life on the edge use cases. So you can click on these links and study up, and after this webcast, of course, and you should be much better to go. So with that, I'm going to pass the baton over to Eric Hibbard, and he's going to lead us carefully through the ISO perspective on the edge. Eric?
All right, thanks, David. So as a bit of a starting point, it's always good to have maybe a bit of a sort of definition or some sort of grounding. There is a published ISO technical report on edge computing. And as part of that technical report, and it came out in 2019, and as part of that, there's actually some definitions, some descriptions. And so from an ISO perspective, what is edge computing? Well, it's data processing and storage that's taking place on nodes. And the word nodes is kind of interesting here, that are near the edge. And what is the edge? Well, the edge is basically the boundary between essentially the digital world and the physical world. So you have these nodes, which are really devices of some sort. Often IoT is often used for them, but in many cases they can be sensors and actuators, but they can be a lot more sophisticated depending on the environment that's running. And these digital entities, these nodes, can vary significantly in terms of a system perspective. Some of them are very low power, very dumb devices. They may be doing just one thing. In other cases, they could be fairly sophisticated, or they could be turned into sophisticated attack weapons. They may not be intended to be sophisticated, but we've seen instances where some of these nodes, for example, video camera systems, can actually be used and exploited. Again, from this ISO perspective, there's a sort of general characterization of a device tier, an edge tier, and a central tier. The way I like to think about it is the device tier is essentially what you've got out on the very, very edge. These are these sensors and actuators, and I guess in theory you might put a car in that kind of a setting, although even in my land that might itself be a combination of these three. The edge tier is often where you see things like gateways. So this is like an aggregation point. It may be a transition point between networks. So for example, you may be going from like 5G to sort of normal internet, although maybe 5G will be the normal internet someday, who knows. And then the central tier is where you get into sort of heavier computing capabilities. But again, it's important to keep in mind that this is a sort of rough structuring, and it can vary significantly depending on your perspective. And we'll give you an example. We'll come back to David's chaos on the edge and show you what could potentially happen. All right, so not only do we have to worry about these tiers, but when we look at edge computing, we've got issues around data plane, control plane, and management plane. So these are things like what kind of data. In many cases, raw data may be moving between the device and the edge tier, but as I mentioned earlier, may actually be filtered going from the edge tier to the central tier. All right, control and management are also important aspects. These are how you over sort of this ecosystem, you ensure that you're getting what you need to be getting, and things are configured correctly. They're on when they're supposed to be on, things of that nature. It's probably an oversimplification. Um, in this diagram, which is also from the ISO technical report 23188, the arrows are sort of abstractions, and the layering here is not a true layering. This does not imply any sort of priorities or things of that nature. All right, so coming back to David's earlier slide, you see on the left-hand side, we're sort of pointing out the central tier, edge tier, and device tier. However, if you were at a sort of different point in the ecosystem, and you look on the right-hand side, you could see, for example, that edge cloud, from your perspective, might actually be the central tier. And then the edge tier might be something that we're currently calling, device tier on the left-hand side. And then the device tier, might actually be, some sort of robotics or drones or cars. Although I always get nervous about including cars in as a true edge device, because it tends to be a lot more complicated than just your average run-of-the-mill IoT. All right. So now that you've been ensconced in edge computing, and before we jump into the security, David, were you going to make a comment, or was that Thomas? Okay. So far, all right. Right.
Yeah, keep going.
All right. So this next piece, we always need to sort of calibrate what we're talking about here, because there's a lot of terminology that people with lots of letters after their names are involved with. And in Thomas and I's case, we operate both in the privacy and the security arena, so a little precision is sort of warranted. So as you see, these circles are basically intended to show that there are relationships between things like privacy and data protection, information security, and cybersecurity, but they're not exactly the same, and they overlap depending on which of these terms you choose to use. Can be significant, in other cases not so much. And as an example, privacy versus information security. So there is some overlap, and the way I would characterize it is privacy has a dependency on information security, but information security in general doesn't have a dependency on privacy. And so that's one way of looking at kind of how these bubbles, are there. Privacy.
I'm going to ask a
Yes,
pre-panel question on this, if I may. Oops. So, is there any sequence to consideration of does one address security first? Do they address privacy concerns? How do they work hand in hand?
In general, if you have no information security program, your privacy program is pretty much in trouble from the start. So you do need some basic level of information security, in particular dealing with things like confidentiality. You have to basically be able to deal with that kind of situation. But in many cases, what you're talking about are certain types of security controls that you're going to need to essentially deal with the kinds of things you need with privacy. So, for example, collection limitations, what that's getting to is you're being careful about what kind of information you're collecting. Well, that has nothing to do with security. However, once you go to store whatever it is you've collected, you've now entered into sort of the domain, on the information security side. And you could basically go through every one of those sort of privacy pieces. The data protection piece is worrying about which of these kinds of data types are are in need of protection and what are the kinds of protections that are effectively needed. Um, and uh, and so they go hand in glove. Cybersecurity, again, is a subset of information security as it's drawn here, in that um, cybersecurity never worries about paper, for example, or potentially training of humans, also known as the weak link. And But information security does. So it's worried about the more comprehensive version. So cybersecurity is more worried about what's going on in the digital world.
Well, let's see. So I take umbrage on that statement. I never been considered to be a weak link, Eric, but that's okay. So Thomas, what would you say that security is the foundation of this? You know, when you're looking at the whole security and privacy infrastructure, or what's your view on this? The heavily regulated one. Oh, how about that? Okay. So Eric, should we move on? Thank you, Thomas, for that insight. So Eric, should we move on to the next slide then, or?
Yeah, yeah. I guess one other sort of data point is, um, in the case of the regulated, um, that can often drive security priorities. So even
Okay.
though the regulation may not be security focused, um, then we've got this issue, um, that uh, that that compliance piece may drive what's going on.
Yeah, we can get into that the next during our panel, I suppose. You know, what from an end user or an application perspective, how do we address not only security but privacy concerns? But let's move on to this quite interesting slide here.
Okay, so this is intended to kind of set the stage, if you will. So we're looking at some of the characteristics of edge computing, that can be different from what you normally would maybe encounter if you're an IT person. Um, and so just sort of going through these fairly quickly. And if you're familiar with IoT, there's probably no big surprises here, but you're talking about massive numbers of nodes. Um, there's often what we call proximity networks. Again, that term is out of the ISO-TR. Um, and what we mean by that is how you potentially interconnect all these nodes, because they may be communicating with each other and interacting with each other, and not necessarily through a gateway or anything else. So that could be actually, for example, a 5G network. Um, this is often your first entrance of the data. Could be massive amounts of data. It's unfiltered data. Think of hundreds of thousands of digital thermometers that are spewing. It's this temperature. It's this temperature. It's this temperature, and it's doing that. Every 10 seconds. But you only care when the temperature is in a certain range. So that's the kind of thing where these nodes are can be very, very chatty. Some of them can work in very harsh environments, so their survivability may be in question. Their and the as part of that, there may be constraints in terms of for example, power. And this gets to sort of the hardware software constraints. Is you may be limited in terms of what you can do with them by design because of where they're going. Imagine putting something in a wall as you're constructing a house. Um, you probably want to be really careful about whatever that node is, because in 5 years it might actually be a source of a problem, and do you want to really go into the wall and basically remove it? There can be high latencies and low reliability kinds of issues with these devices. So they may have very, very low speed connections, and just due to the harsh environments, they may come and go based on sort of events around them. There can be localized compute, storage, and management issues with these. So that's completely independent of the overall ecosystem. And last but not least is we're talking about potentially very heterogeneous nodes with radically different feature sets. Some may or may not have any security capabilities at all. Others may actually have fairly advanced. Um, Now, on the challenges side, some of this translates into some issues that are worth noting. So, um, with an edge computing kind of scenario, especially with clouds, this is a little different kind of mode of operating than how clouds are often used today. When you think of private, public, and hybrid kinds of clouds, for edge, this is a sort of different way of looking at it. Um, the the traditional things like firewalls and VPNs and intrusion detection systems and intrusion protection systems really don't apply in most of these ecosystems. They may be appropriate for sort of the central tier, but outside of that, there just may not be any way to do that. Um, because of the heterogeneity, um, in terms of things like orchestration and sort of automated control and management, gets really, really difficult. There may be lots of difficulty in terms of setting access control policies, and in particular enforcing them, especially if you've got multiple security domains and these devices or these nodes are sitting in those. The interfaces and protocols that are being used, are likely to be very insecure. Um, and even if they are secure protocols, they may not be using them in a secure manner. As we've seen in the past with some camera systems, uh, very susceptible to distributed denial of service attacks, in that they can actually be participating in it, but they could also be subject to it. So you may have for example, a nuclear power plant that may have certain kinds of sensors that are extremely important to the operation of the facility. And if somebody mounts a DDoS attack on it, that could cause problems. And of course, this is an expanded attack surface because you're just talking about sheer numbers of items here. So this is this is the chaos or the mess that we're looking at from through the lens of a security person, kind of going, oh my goodness.
Okay, so let's hang on this one for a second. So if I was given an assignment to say, okay, deploy this data analytics accelerator across a cloud to edge infrastructure and make sure our customers' data is kept nice and safe and private. And I look at these lists from the two of you industry security experts. What would I think? What would I do as my next step? I mean, this is somewhat overwhelming.
Yeah, welcome to our planet.
Yeah.
um, so yeah, the short answer, and this is kind of like the lawyer gives you the depend standard answer. So from the security angle, it's all about risk, and so you really do want to look at one of these ecosystems and try to understand, um, you know, what data is most important, what systems that touch that are most important. So critical path, understanding the critical data, understanding the critical path, and then looking at that, from a risk perspective, to see what you can do to minimize, problems that could exist and will exist in these environments. It's just it's the nature of the beast, if you will. That said, when you start looking at it through the lens of risk, then you can take reasonable steps to mitigate what you see there, and invest wisely and establish your priorities. And that's really uh, um, the basic sort of how to deal with this. And as you'll see as we get into it a little further, there's sort of different facets of this that you've got to worry about. So some of these you can do in parallel, but it really comes down to follow the data and or the money, because that's what the attackers are going to do. And so as long as you understand what data and potential financial kinds of things you're dealing with, then you have some possibility of dealing with that.
Hmm.
Did I
So
answer
think
on
like
that
a
okay?
bad actor.
Well, you have to think like a bad actor. You and I have had conversations where use cases. I'm always about abuse cases, and as you're seeing in this slide, this is a target-rich environment.
Yeah. Well, let's move on to the next slide.
Okay, so and I kind of alluded to this already.
There you go. All
So
right.
understanding threats, and what we're seeing right now and some early work within the ISO sort of security arena, looking at threats, focusing on things like the node threats versus network versus data versus applications, and at least as a starting point, kind of understanding what you're dealing with, and then you can sort of move to how do you sort of mitigate it. So on the node side, physical security is going to be one of the issues that's going to be problematic, and so you've really got to understand what you potentially need to do there. You're also dealing with a set of devices that may or may not have any security capabilities or extremely limited. And think about this: if you've got low power requirements, odds are you're not going to have a crypto chip in there that is going to be a bit power hungry to do any sort of serious encryption, even if it's just for communication. There are problems with a lot of unmanaged devices. They may have default configurations which nobody's adjusted. It may be difficult to actually deal with this stuff. There may be software vulnerabilities in the products. Again, there may not be any ability to patch these. If there are, you're going to clearly want to know how to go about doing that. And of course, malware is not restricted to your favorite PC box or Apple box. It's permeates lots of infrastructure. So when we look at these nodes, these are the kinds of threats that are often there, and you have to look at them at least as a class and see which of these are a problem for your ecosystem, and then how to go about dealing with them. In some cases, um, you may want to ponder these prior to making purchases because you may find that the cheap investment for the node up front was nice, but when you go to actually manage these things all term, these things can kill you from a cost perspective. And likewise, there's issues under the networking side. None of these are really earth shattering kind of things. You've got protocols that may or may not be secure. Denial of service, I already talked about. Eavesdropping and spoofing. So basically somebody's monitoring what you're doing and taking advantage of your day. Spoofing, they may be trying to trick you into believing that that temperature sensor is just gone red. um, and there may be problems with network configurations. On the data
Okay.
side, again, pretty simple. It's disclosure, corruption, destruction, and availability. These are all sort of heart and soul. If you look at sort of the privacy world, these are the kinds of things that there's a lot of worry about. Applications are similar problems as nodes, but there may be application specific vulnerabilities, and again, there may not be updates for the applications, and of course, authorization or access controls may not be what they need to be, or they may be configured in a default setting where everybody's got root or admin access, which may not be appropriate. So, from a threat perspective, these are the kinds of things that that we're considering when we look at these kinds of ecosystems. Um, the severity of these will depend on how the node or the servers or the cloud components, what role they play. Okay.
So let's go into that some more, Thomas. Right. So on say let's start with applications. If you could maybe give some help us understand from an application standpoint those comments you made. Yeah. So, Thomas, could you contain or isolate if an attack happens so that it doesn't propagate through the system? Are there methodologies to do that to protect your data, or if it's exposed, at least contain the threat or the attack?
So yeah, so containing the threat, interesting. um, again, this is it's clearly going to depend on kind of where in the ecosystem you are you're operating. So if you're at the cloud level, there's a lot of protections that are in place in many of the cloud service providers, and even in the edge cloud, coming back to your diagram, that most likely is going to have some sort of capabilities that you can take advantage of, whether it's encryption of sort of the data in flight, or the data resident may actually be encrypted as well. But you move out to nodes, and I like to use the example we had a few years ago, where these video cameras were installed in lots of different locations in a particular city, and an attacker succeeded in essentially gaining access and um, effectively using those cameras then to target a single website, and you just inundated it with lots of information that effectively took it offline for an extended period of time, and it because it involved a massive number of these little camera systems. It's really difficult to sort of, how do you contain that or mitigate that, because they were coming in on all these different IP addresses, so you couldn't filter on things like IP addresses and whatnot. So this is one of those where in some cases, if you could see that there's a particular protocol that's being used, or something of that nature, you might be able to filter on it. But in other instances, you've got to use other sort of throttling techniques and whatnot. This means you've got to, if you're a defender, you've got to recognize when you've got a attack of a certain nature kind of underway, and be able to adjust your ecosystem, and the controls you have in your ecosystem to mitigate it. You may not be able to eliminate it completely, and especially if it's like a 0-day event, it can be very difficult to even understand, what's the exact nature of the attack.
Okay. Well, why don't we move on to the next slide?
Sure. So the next slide, and this is coming back to from a security perspective. We've been talking about threats and issues and characteristics and whatnot. So when we look at security in general, what are the kinds of things that we're going to have to worry about? And in a simplistic way, they're definitely going to be around physical security, and that's going to be across all of the tiers, but it will vary radically depending on the tier. You've got security operations and maintenance. So think of this as things like setting up the initial control and configurations, doing updates and patching, just monitoring what's going on in your ecosystem. So if you see a particular device as doing something weird, or it's logging is kind of odd, you may be able to take advantage of that. Infrastructure security, this is going to be more relevant to sort of the edge tier and the central tier, where you actually have maybe real servers, real systems, and how they're configured, how they're designed to interact, and potentially their interaction with the nodes. Although it's in the sort of multi-tiered scenario, what we're seeing is direct interaction between the nodes and the central tier happens sort of less likely because you want to do some filtering. The network security is definitely going to be tricky. If you think about how you're dealing with networks and just TCP/IP, for example, we have lots of challenges in that space now. Now you're talking about bridging maybe 5G and I'm using bridging loosely here, security as opposed to a network engineer. So moving between, for example, 5G and IP networking, but there are other protocols out there. So you could be using maybe some sort of Bluetooth, infrared, and there's a whole bunch of other uh, technologies that get used that are proximity oriented. Maybe in a household, for example, and how you secure those throughout the sort of the ecosystem end to end is going to be a challenge, because we know from experience that doing sort of hop to hop network connections can be a problem.
Well, I'm staring at this red safety cross and I'm gonna press it, and hopefully Thomas is going to come to my rescue here. So I've pressed the button virtually.
He's pressed the red safety buttons. Thomas,
Yeah.
what do you think
So
about
Thomas,
safety?
help me out here.
It's a big
Erica's going deep on this topic. Pull me up a level.
big red safety button. That's always a good one. Can you guys hear me okay?
Yeah, you're
I
good.
can.
Okay, good. So, yeah, so a lot of, interestingly enough, a lot of the aspects of security that we talk about day in and day out often don't really cover this concept of safety. And really, what are we talking about? What we're talking about is really human safety, right? So, as much as we'd like to not consider it in many cases, a lot of the security controls that are put in will eventually really come down to potentially actual human safety. And so there's many great examples out there. Not to pick on any given vendor, so I'll try and be sort of generic when I talk about it. But for example, in this whole, IoT space where you're doing things with remote controlled things, maybe a vehicle, for example, and it's going down the road and someone spoofs it and does the malicious thing and it has it run into a telephone pole. It's okay if it's a car that has absolutely nothing in it with no humans, but totally different thing if they're actually uh, remote controlling a car that actually has a human in it, and the effects could be devastating from a human capital perspective. And that's just one example. And we can go into many more examples, but just to give you a feel for what that's really referring to.
Well, here, I just learned that automobiles, the data that with the number of sensors that the data that's being developed, it's terabytes and terabytes and terabytes. So how do you make sense of all that data and sift through and get ahead of the attacker before the attack happens? Because last time I checked, most cars have drivers and people in them, either in the front seat and maybe tomorrow just in the back seat.
Well, if you go back just a few years to some of the security conferences where they were looking at these vehicles that have more and more electronics built into them, there are real live instances where somebody basically pulls up next to you as you're driving down the road, and all of a sudden your vehicle shuts off via an attack. That might have a small impact if you're doing 75 or 80 miles an hour down the road. Not that I drive 75 or 80 miles an hour down the road, but your power steering is no longer power steering. Your power brakes are no longer power brakes, and if you're not prepared to deal with kind of what you're left with when something like that happens, and that's those were early examples of the concerns, looking at, for example, vehicles as more and more smarts are embedded in it. that you could have somebody do a simplistic attack of essentially just turn the engine off, and that's the kind of thing that after it was demonstrated, the automobile industry went, maybe we should protect against that, and there are definitely efforts have been expended to deal with those kinds of problems, but as vehicles get increasingly sophisticated, the attack surface isn't just one sort of entry point. These vehicles are now ecosystems in and of themselves, and so attackers are looking at vehicles. They're high value targets, and if they can mess with one of those, or imagine a ransomware attack on a particular brand of car. Wouldn't that be fun? None of our cars will start. So these are the kinds of things that when we look at these complex ecosystems, the attackers, they're after data, but in some cases, depriving you of your data or depriving you of access to whatever it is that you want to use is just as good. They can make money off of that. They can cause, mayhem. And in some cases, that's the desire, is just to be, not only annoying, but disruptive, causing, impacts on economies and whatnot.
Well, let's move on to the next slide, because I want to get into our lightning round panel, and here it is. Perfect. So I think, here we are, and what a great foundation and setting. It's like you're writing a story, right? Now we're what are we going to do next? What are we going to do? Don't leave us hanging, you security experts, you. So, but I did learn during this discussion so far is that, risk can be managed, and each of these ecosystems, they're quite complex and they have their own idiosyncrasies to them. So, if you were talking to a business owner at a large company and wanted to deploy one of these applications, how would you basically summarize the approach to manage the risk and articulate it in such a way that you understood what the complexities of the ecosystem involved were and how you were going to address security across that ecosystem? So maybe I'm going to start with Thomas on that one, because he's nodding his head.
Yeah, it's a great point. So in talking to an executive at a company that's interested in this type of deployment, let's say edge computing to do some great things out on the edge with IoT type devices, typically, there's a bunch of things to consider. The security controls are going to be very important based on what those specific risks are, and also, again, back to what are you doing out there on the edge? Or is it controlling remote cars versus just checking temperatures in a data center, for example? Not that one is worse than the other, but I'm not trying to make a judgment there, but it's going to be very different from a risk perspective as to what's going to be your focus, your priority as a company. So first of all, number one, I would always talk about what are you going to do? What's your goal? How is it going to be deployed? And then what can your company afford to do based on the risk that we see that's there in front of you? And the interesting part for me is going from company to company is the risk profile is very different, and you wouldn't necessarily that. Maybe it's not even necessarily intuitive, but the type of risk that they're willing to take on based on what they're trying to do out there on the edge with IoT devices, very different from company to company, for better or for worse. But it's all based on what they can afford to apply that risk towards.
Okay, well, that's quite interesting. So, Eric, even on that point, Thomas has suggested there's a spectrum of risk tolerance from company to company, from application to application. What say you on that point?
Well, I would tend to agree, and I guess the additional point I would make is, you it may be somewhat dependent on how much fun you've had with the legal community and regulators. If you've never tasted the whip of the FTC, or you've never had a New York lawyer take you to task in court, you know you and he owns your company when he's done. They're this is the part where the risk tolerance of an organization can actually be a detriment, because they don't always know what they don't know. And I guess, sort of coming back to the question that you asked, I think what I would also add to that is, think about this long term. So if you are successful with what you're trying to do, where would you take it next? And if you were at that sort of next phase, would you have all the pieces that you would need to have? So, and the reason that's important is, if you build a prototype, and yeah, we don't need no security on the prototype, but then you turn that prototype into a production system, you're kind of screwed, because you didn't even think about the security implications. And in the case of the prototype, you didn't need it. And so this is the part where, and we see this often with technologists. It's, can we do it? And the question of should we have done it never sort of enters their mind. And frankly speaking, this is where a lot of lawyers and regulators, they're operating in that space of, really, you actually did that, and you didn't tell anybody.
Yeah.
Okay.
So that's an opportunity. I think, just in a product planning type of strategic planning role, that security, what I'm hearing, should be thought of at the get-go, not as a detriment, but certainly equally weighted in the equation in
You
developing
don't bolt
products
on
and
security.
solutions.
Yeah. You
Yeah.
don't bolt on security. Or if you do, you get this Frankenstein, when you're done, and you're probably only going to solve half of what you really need to solve.
Yes. So, how about privacy? We touched on that a little bit, and that can be application driven as well. How do we address that? If now we've all agreed we need to be proactive on when we build out solutions and define what they are in the first place from a security standpoint. How about privacy concerns? I mean, is that working hand in hand with the customers and the market? How do you address that one?
Privacy is tricky, because it's jurisdictional. So in the United States, we don't necessarily have a whole lot of an expanded set of privacy rights, but depending on what state you live in, that can change. Whereas if you're in Europe, there's a whole bunch of different things that are basically protected. So that is definitely a complicating factor. However, again, when you look at the privacy angle, it is important to understand what are you collecting that could be exploited, in some fashion. What have you could it identify somebody? Could it identify something about the individual that they wouldn't want to actually have disclosed? And
Okay.
the thing I it always gives me kind of a chuckle is the father that gets all angry when a set of coupons come in for diapers for his daughter, and then he finds out his daughter's pregnant. How did they know? Well, therein lies the secret sauce,
Oh my
because
gosh.
certain indirect information's been collected, and when pickles and ice cream, I'm being a bit facetious, when pickles and ice cream and something else are purchased, it's an indicator. And so that indicate, all right, so, those kind of scenarios where you're harvesting details about humans and how they interact with their environments that give you insights. There's value in that from a marketing standpoint, if you will, a product perspective, but it's also can be very dangerous in terms of what it exposes about the individual, and those individuals may not want any of that information out there. So what you have to do to protect that is definitely jurisdictional based, and so you got to understand where you're operating and who you're dealing with.
Okay. Well, that's a pretty scary example that you brought up for any parent that's got a daughter. So they're going to be checking out their latest, coupons in the mailbox for diapers. But Thomas, how about a closing thought on security? Basically, what we've talked about today.
Yeah.
What's your takeaway for us all here?
Yeah, so a couple of things. I'll try and keep it brief because I know we're towards the end, but I'll say one thing about privacy. The interesting thing, in addition to what Eric had mentioned, is not only is it jurisdictional because the issues are different from a legal perspective based on geography and where you are. It's also interesting to note that from a privacy perspective, that data that's collected, how did that data start to get collected in the first place? A lot of what came out of things like GDPR, for example, one of the concepts that's there, and that's just one example, but the idea of having to opt in to things like certain types of data collection. In years past, that wasn't necessarily a thing. If the privacy policy wasn't specific enough, you were giving information based on you being on a website doing certain things without the ability or even knowing what was happening with that data once you were on that website, just as an example. We're starting to see a lot more regulation now in multiple regions around the world that are very specific about forcing companies that do want to collect data. They have to ask permission first before they even start.
Okay. Well, thank you, Thomas, for that. I mean, I don't feel a lot better because, or if that's grammatically correct, I don't feel comfortable with the security and privacy issues, but I certainly do feel comfortable that we have two experts here that can lead us through this maze of cloud to edge applications and risk management scenarios that we need to address. So, the takeaway here from what we talked about, and I'll just run through this, is that security issues, they do permeate across the edge, and they're the ecosystems as well. There's all sorts of different widgets, heterogeneity, complicating security as well as privacy. There's no one size fits all. We talked about that. We really need to look at it from an application standpoint and from a risk management standpoint. Privacy implications also need to be addressed. And Thomas, you did a nice job, as well as Eric, on introducing us to that. Give it equal weighting and consideration with security. And lastly, in some scenarios, safety can dominate the security priorities. So that was that red button that I pressed because I was getting in a little too deep, and thankfully Thomas and Eric pulled me out of that. So I would like to thank, first of all, our panelists, Eric and Thomas, for doing a bang-up job on basically illuminating us on the details and considerations across security and privacy. And my takeaway is that we need experts like this that can help us make sense of all this, and they're doing a good job on that so far, for sure. So, as I mentioned earlier, to learn up on the overall edge to cloud infrastructure, please look at our first webcast. and then go into the use cases on our second webcast. And then just so you know, we have a security summit on May 11th. The SNIA Storage Security Summit. Please click on this link below or the QR code. And this will really get you in deeper on in the topics that both Eric and Thomas covered today. So with that, after the webcast, please take time to look at our educational library. We will be sending out the Q&A so that you'll be able to see that. It'll be posted on our blog, and follow us on Twitter at SNIA NSF. And lastly, thank you for your attendance. Feel free to give us your feedback and enjoy the rest of your day.
Thanks, everybody. Cheers.
Bye now.